Hello, I'm Paul Wu, the founder of Team Model Smarter Education. I am honored to represent the Team Model team at the World Association of Lesson Studies International Conference to share with you the foundation, structure, functions of the Team Model Smarter Education System platform. Team Model platform is a teaching technology system that our team has been developing for more than 20 years. It is a complete digital solution that fully utilizes information technology, AI, big data to support teachers' teaching, assist students' learning, accelerate teacher professional development, and promote the development of smarter school. In the following, we present our system in three parts: the foundation, the structure, and the functions of Team Model platform.
Hello, I'm Johnny from Team Model team, and I'm going to introduce to you the foundation, the structure, and the functions of Team Model platform. First is the foundation of Team Model platform. Why did we develop the Team Model platform? The global education trend is mentioning a very important thing, that is, to integrate technology with our current education. In 2006, this matter was emphasized by the TPAC theory. TPAC emphasized that the subject content knowledge, the pedagogy knowledge of the teacher, and the knowledge of technology should be effectively integrated together. Therefore, in order to realize this concept, we developed the team model system. Why is the team model called team model? It is to be able to carry out the four important components in teaching, including teaching itself, assessing, diagnosing, and finally remediation. These four components basically constitute the most important elements of teaching as a whole. We hope we can use the benefits of technology to make them more effective and efficient, which is our most important goal in the development of this system. So once we have an excellent support system in place and a deeply integrated theory like TPAC, our team put together a learning method called Team Model-based Smarter Learning. This learning method is based on the team model system and is one of the best ways to implement the TPAC theory. Through TBSL, we hope to achieve three important things: effective interaction, synchronized differentiation, and autonomy under group learning. The most important key to achieving these three things is data-driven decision-making. That is, through AI to collect all the data in the classroom and in teaching. Then the teacher will be able to track the student's learning situation in real time and achieve effective interaction. And then based on every student's learning situation to be able to do synchronized differentiation. And because each student in a classroom has his or her own device, they can work together as a group, but they can also learn independently. To achieve the vision of TBSL, the most important thing is that teachers must become smarter teachers. Therefore, we have proposed a three-tiered scaffolding theory. The teacher professional development scaffolding for this purpose. These three layers build up the internal and external skills of a smarter teacher. The first layer is our smart teacher. It emphasizes the four items of RICS as the most important internal basic skills of a teacher. The second layer is TPC that we just talked about, how to refine a smarter model. And the third layer is the DIA, which is the important and necessary ability in the smarter classroom. We welcome you to read further content of TPDS. The most important purpose that we propose TPDS is to be able to practice teacher professional development. To make a small conclusion, Team Model system is formed with a theoretical basis of global education trend, plus our own developed teaching support system and modern technology, including AI and big data application. We hope to provide all teachers and schools with the most comprehensive, smart education solutions. Next, what is the structure of team model? First is the teaching system we mentioned earlier, which is the tool that allows teachers to put TPC into practice in their lessons. The other is our lesson observation platform, as lesson observation is an important part of teacher professional development. We first look at the smarter teaching system. We can divide it into two rules of application: teachers and students. For teachers, HiTeach is a system that can provide complete tools and materials in the classroom. And also, we developed HiTA, an app that allows teachers to connect with HiTeach and then control HiTeach function or upload files in real time. For students to interact effectively with the teachers, students must have an interactive tool at hand, which will be referred to our WebRS. WebRS can be used on smartphones, tablets, or computers. Students can interact effectively and efficiently with their teachers through their devices in real time, whether they are on-site or remotely online. On the other hand, in such a smarter classroom, how does the lesson observation platform mentioned just now work? Actually, while we are in the classroom, we can collect and integrate all the data and images of a lesson through the AI terminal. And what content will it collect? The first and most direct is the video recording of the lesson itself. So, there must be cameras in the classroom in lesson observation, which can record the teacher's teaching and the student's learning. Second, the teacher and students will interact with each other through WebRS, ask questions, and perform tasks. And all these teaching data will be recorded together. The third one is that when the lesson is being observed, the observing experts and teachers can use their own smartphones or computers to type down all the ideas and suggestions directly during the lesson. And each recorded feedback of the lesson will also be integrated through the AI terminal. So when we finish a complete smarter lesson observation, all the above mentioned data will be automatically uploaded to the cloud, and we can see what functions we can have. We'll divide the functions into four main parts. The first one is the part of the smarter lesson observation mentioned just now. Then, we will focus on what the system can do through AI analysis and data, and how the system can compile the comments and records given by the experts and lesson observers. Finally, how will a complete lesson be saved and used in the cloud? Let's start with the conclusion. A complete smarter lesson upload to the cloud will have several important things that can be produced, including Socrates video, Socrates report, a complete lesson observation form, the lesson plan, teaching materials, and an Excel observation report of the lesson. Let's look at them one by one. The first is that when we conduct a lesson observation, the observing teachers do not need to hold a pen and paper to record. They just need to have a smartphone or computer to access our lesson observation platform, and then they can leave their feedbacks at any point of the lesson. This feedback can include text, image, audio, or video. In addition, the most important thing is the type of focus category of the lesson observation can be customized by each school. Each school may have a different focus on lesson observation, so the schools can set the focus of the lesson observation for teachers to use. And when we complete such a lesson observation, the first thing the system automatically helps you generate is the Socrates report. There are two important elements in the Socrates report. The first one is the Socrates data. Our AI Socrates, through machine learning, has seen more than 100,000 lessons on the platform. So after each lesson is uploaded, AI will automatically give a T and P index for the status of the technology interaction and the status of the pedagogical application generated by technology. so that teachers can see the first results of their own lesson in TPC integration. Below is a complete record of what high-teach function the teacher used from the first minute to the end of the lesson, so teachers can clearly see the whole lesson context. Next, combining the video recorded with Socrates reports is our Socrates video. In the Socrates video, you can see the complete record of the whole lesson, including the lesson video, the teaching characteristic of the teacher mentioned just now, the relevant TPC data, and also each feedback from the observing experts. Let's take a look at the Socrates video interface. There is information about the lesson, the video itself, the teaching behavioral data characteristics from the beginning to the end of the lesson, all the feedback given by the observer and the photos or other files attached. Down here are hotspots. When many observers give feedbacks at the same time in the lesson, there will be a peak, and you will be able to see where the key, the most exciting, or the most important time point for discussion in this lesson. Over here, we not only can see all the feedback from the observers, but I can also select the feedback from any observer I want through the filtering function. I can also select a specific focus category of the lesson, like I can see those that have questions, or I can choose to select the ones that give the lesson some ideas on corporate learning. And not only can you give feedback during the lesson, but even afterward, you can watch the video yourself and add comments. In other words, we not only can do synchronized lesson observation, but also asynchronous lesson observation. All the data recorded in the lesson are not only recorded here, but each data is linked to the video. In other words, if I want to ask an expert to share a comment that he or she gave when observing the lesson, I can click on it, and the video will automatically jump to play that time point, so that everyone can see the situation of the lesson at that time, and everyone will not have to recall what the teacher did at that time. I can also click on the hotspots or certain high-teach function the teacher used and play the video of that time. I can also export the reports and comments from the lesson observation into a PDF file or an Excel file. Both can be used for data storage. Lastly, each lesson uploaded to the cloud is saved in its own exclusive channel. If I am a teacher at School A, my lessons would be saved on School A's channel. And as teachers at School A continue to teach, the channel will have abundant lessons, and each lesson will become the most important materials for lesson study or for teacher communities to discuss teacher professional development. Also, there are even school-to-school partnerships, school district channels on our platform. You can see hundreds of channels on our platform, filled with all kinds of wonderful lessons from all over the world, which is the best platform for teachers to learn about each other and enhance their professional development. This is an introduction to the foundation, structure, and functions of team model.
Hello, I am Stephen Liang, another founder of Team Model Smarter Education. By promoting teacher professional development, we can improve the quality of teaching and learning, which in turn will lead to the achievement of each child. This is the core development concept of Team Model Smarter Education. Therefore, we focus on classroom research and analyze the data characteristics of teaching behavior with the help of AI security system, helping teachers to deeply integrate TPAC, technology, pedagogy, and content to accelerate the teacher professional development. Once again, we thank you for listening and look forward to receiving valuable guidance from you. In promoting teachers' professionalism, developing a shared platform, and establishing a collaborative ecosystem of smart education. Together,